Welcome to Fluid Mechanics lectures by Civil Thinking, and today we are going to solve a problem on dimensional analysis. The method is Buckingham's pi method. Okay, now the problem is on your screen. Deduce the general formula for the expression for drag force Fd on a solid sphere of diameter d, which is held fixed in a fluid stream that moves at a uniform speed u. Okay. Begin with the assumption that Fd is some function of u, d, mu, and rho, where nu and rho are fluid viscosity and density respectively. Using this assumption, show that Fd can be expressed in the form Fd equal to rho u square d square, function of Reynolds number. Okay, Re is Reynolds number, which is rho u d upon mu. Now the problem is something like this. You have some fluid here. Okay, now the velocity of the fluid is u. Okay, this is u, this is a moving fluid, and in the moving fluid there is a sphere. Okay, because I'm using two dimensions, so I will use denote the sphere with a circle. Okay, let me say it's like this. Now this sphere is fixed. Okay, the velocity, the stream is moving against it. Okay, the diameter of this is d. Okay, now what we have to find, now we know when there is a fluid flowing on this surface like this and like this, right, what is going to happen, there will be a drag force on this. Okay, there will be a lift. Okay, because this fluid, it is going to apply some drag. Okay, like this, the drag force will be on the whole surface. Okay, this water or this fluid will try to drag, apply a force on the surface of the sphere. Okay, let me denote this with Fd, and with the help of dimensional analysis and specifically Buckingham's pi method, we have to find the equation of drag. Okay, we have to find this now, so let's begin. Now we are asked, now we are told to assume that Fd, drag force, it is a function of u, which is the velocity, d is the diameter of the sphere, mu is the viscosity of the fluid, and rho is the density of the medium, of the solid. Okay, and rho is the density of the solid sphere. So we can assume this to be a function of u, d, mu, rho. Okay, now we can solve this problem very easily using Rayleigh's method. Now because we are talking about Buckingham's pi method, so let's solve this problem using Buckingham's pi method. Okay, now usually we use Buckingham's method when the number of variables are more than or equal to 6. Okay, now here if you see, now when we talk about Buckingham method, we have to assume it like this. It is a function of another function of Fd u d mu rho. Okay, now how many variables are these? It is 1 2 3 4 5. Okay, now the number of variables are 5. Okay, although we could have used the Rayleigh method, but now I will be using Buckingham's method. So the number of unknowns are 5. Okay, now this function is equal to 0. Let me first write that, because drag force is a function of this, so when we convert it into a zero variable function, it is going to be equal to 0. Okay, again here 1 2 3 4 5. Okay, the number of variables n, right, n is 5. Now what are the number of dimensions? Okay, now you see Fd, it is a drag force, right? Now what are the dimensional units of the drag force or the force? It is m1 l1 t minus 2. Okay, these are the dimensions dimensional units of force. Okay, if you don't know about this, please comment and I will explain it more. Now u, next is u. What is u? U is velocity of the stream. Okay, it is meter per second, means L1 t minus 1. Now d, d is the diameter of the sphere, it is L1. Okay, now what's left? Now we have mu. Mu is viscosity. Now what are the units of mu? M1 L minus 1 T minus 1. And rho, it is the density of the sphere, it is mass per unit volume. Okay, M1 L minus 3. You can see which is the highest term. Now here you can see here is no M, here is no T, here is only L. Okay, here only dimension is L, here are 2. Now if you see all of these equations, the maximum number of terms are 2 only. Okay, 1 M L and T. Here it is only 2, but it is in drag force and the viscosity, the maximum number of terms are 3, M L and T. So the number of basic dimensions are 3. So the number of pi terms, okay, the number of pi terms is equal to how much? N minus M, which is equal to 2. Okay, so we have only pi 1 and pi 2, right? Now we have to find the value of pi 1 and pi 2, and that's it. We will get the drag force equation. So let me erase this first. Now we have pi 1 and pi 2. F1 of pi 1 and pi 2 equal to 0. Okay, because these are the number of pi terms are 2. Okay, this is the procedure of Buckingham pi method. This is how you solve. Now pi 1, we have to find the value of pi 1 and the value of pi 2. Now we always have to choose the repeating variables. Okay, in the Buckingham method, repeating variables. Now repeating variable, let me choose repeating variables to be d, u and rho. Okay, this d, u and rho, I choose these three terms as the repeating variables. Then we are left with non-repeating variables, which are drag force itself and the viscosity. So pi 1 will be equal to first the repeating variables d, u, rho, and let me choose one non-repeating variable with it. Okay, it can be fd or mu, it's our choice. Let me begin with fd. Okay, now I will assume some arbitrary coefficients. Pi 1 equal to d raised power a1, u raised power b1, rho raised power c1 multiplied by fd, and pi 2 is d raised power a2, u raised power b2, rho raised power c2 multiplied by not fd. What is another non-repeating variable? I have already used this fd here in the pi 1. So in the pi 2, I will use this mu. Okay, now we know pi 1 and pi 2, they are they are constants, means they don't have unit. Okay, now when I talk about pi 1, if I write it here, okay, now pi 1 is m0 l0 t0 is equal to, now what are the units of d? As I have shown before, d is a length, so it is only l raised power a1, right? Then u is velocity, which is meter per second, l t minus 1 raised power b1. Rho is the density, it is mass per unit volume, power c1, and then we have force, it is m1 l1 t minus 2. Okay, now all of these terms are in multiplication. Okay, now let's compare the power of m in each term. Okay, now here the power of m is 0. Okay, I'm talking about the power of m. 0 is equal to, where is m? Here is m power c1, so it is equal to c1. Here is plus 1, right? So here I will get c1 to be minus 1, right? Now let me compare the power of L. Okay, now here what is the power of L? It is 0 is equal to, what is the power of L here? No, now let me compare the power of T first. Okay, then I will compare power of L, because T terms are very little, so the little terms are to be written first. In this way you will save a lot of time, trust me. Now the power of T is 0 is equal to minus b1 minus 2. Okay, so here you get b1 to be minus 2, right? Now let me compare the power of L. Now L, here the power is 0, is here is a1, here is b1 will get, okay, into the power of L, so it is plus b1. Now here it is, power of L is minus 3 will be multiplied by with c1, right? So it is minus 3 c1, and here the power of L is 1 plus 1, so a1 0 is a1 plus b1 is minus 2, right? Minus 3 c1, c1 is minus 1, so it is going to be plus 3 plus 1. Okay, now it is going to be 3 plus 1 is 4, 4 minus 2 is 2, so it is going to be a1 plus 2, or we can say a1 is minus 2, right? Now here we get the power of all these terms. Okay, a1, b1 and c1. So let me write the values here. a1 is minus 2, b1 is minus 2 and c1 is minus 1, right? So I will erase everything here. Now what we will get pi 1 to be d1 power a1, right? Now a1 is minus 2, right? As you can see here, d power minus 2. Now u power b1, b1 is again minus 2, as you can see here, and c1 is minus 1. Rho power minus 1 ft. Okay, now when I rearrange this, I am going to get pi 1 to be fd divided by d square u square rho. Okay, or I can rearrange it to be fd divided by rho u square d square. Okay, I just rearranged this, nothing much. So finally what we get the value, we get the pi term, right? So what we get the pi 1, we get pi 1 to be fd divided by rho u square d square. Okay, so let me erase all of this. Now before I move on, I want to tell you that you can download the PDF. Okay, PDF of this numerical problem. The link to download the problem is in the description, and also if you have any problems in the fluid mechanics, you can ask me. I will also provide the link to contact me. It will be in the description. Okay, now let's move on. Now we have pi 2 like this, so let me put pi 2 here. This is our pi 2, right? Now pi 2, it is dimensionless, so it is m naught l naught t naught. Okay, now d again, it is what? L1 power a2. Now u is velocity per second, velocity, right? It is meter per second, it is l t minus 1 b2. Now rho is mass per unit volume, which is m1 l minus 3 power c2, and mu is m1 l minus 1 t minus 1. Okay, now let's equate the powers. Now let me first equate the power of m. Here the power of m is 0, so I will be 0. Now 0 is equal to, where is m term here? Okay, here it is c2. Here the power of m is 1, so it is plus 1. Now why I am adding this? Because these m power c2 and m power 1, they are in multiplication. Okay, it is like this: m power 1 multiplied by m power c2. Okay, m power 1 multiplied by m power c2, right? Now in the multiplication, when the bases are same, powers are added. Okay, so it is m power 1 plus c2, okay, or c2 plus 1. So the power of m is what? 1 plus c2. Okay, 1 plus c2. Okay, if I am fast or something, if you have any problem, please let me know in the comments. So here we found value of c2 to be minus 1, right? Now let me compare the power of t. Okay, why? Because t terms are less, and when you compare the terms with lesser terms first, it will save your time. Okay, now here the power of t is 0 is, here the power of t is what? It is not minus 1 because b2 is again here. Okay, b2 will be multiplied by with minus 1, it will be minus b2. So here the power of b2 is, t is minus b2, and here the power is minus 1. I think that's all. We only have these t terms here and here. Okay, so from here we can get the value of b2 is minus 1, right? Now let me come equate the power of L. So it is 0 is equal to a2 plus b2 minus 3c2. What is the L here? It is minus 1, right? See, a2, right? Power of L here is a2. a2 multiplied by 1 is a2, right? So it is a2 plus b2, L power b2, right? b2 will be in the power of L. Here it is minus 3c2, so minus 3c2, here is minus 1. Now c2 is minus 1, b2 is minus 1. So when I put these, I will get 0 to be a2 plus b2 is minus 1 minus 3c2. It is c2 is minus 1, so it is plus 3 minus 1. It is 3 minus 2. So here we get 0 is equal to, now it is 3 minus 1 and minus 1 is 2. So 3 minus 2 is 1, a2 plus 1. So here we get a2 to be minus 1, right? So here we found what? We found a2 equal to b2 equal to c2 equal to minus 1, right? So we found the values. So let me erase these things. Now let's put the value of a2, b2, c2 in the pi2 term. So we will get pi2 to be d power a2, d power minus 1. Now a2, b2, c2, all of them is minus 1, right? As we can see here. So it is d power minus 1, u power minus 1, rho power minus 1 mu. So when we simplify this, we are going to get pi2 to be d, or let me rearrange it like this, rho u d. Okay, now this is the pi2 term. Pi2 is mu upon rho u d. Okay, now if you know the Reynolds number, Re is Reynolds number, it is rho u d upon nu. Okay, this is the Reynolds number, so it is the inverse of Reynolds number, 1 upon Re, or you can just write it as Re2. Why? Because pi2 is constant. It doesn't matter if you write 1 upon Re or if you invert it. Okay, you can also write it as Re, but remember Re is this. Okay, it is not this, but we can inverse the terms because here it is pi term. Okay, so pi2 is Reynolds number, right? Reynolds number. So let me erase this. Now because this is function is equal to 0 and we have two terms, so we have function of pi1 and pi2 is 0. Okay, now here we will put the value of pi1 and pi2. Okay, it is function of fd divided by rho u square d square comma Re is 0, right? Now we can also write it like this: Fd drag force divided by rho u square d square is another function. Okay, it is another function of Reynolds number, or I can put the denominator in this direction, so I will get rho u square d square function of Reynolds number. So you can see here rho u square d square function of Reynolds number, and we got it. Okay, we found the equation of drag force. Okay, now again, if you want to download the PDF, you can download it in the description. If you have any fluid mechanics problem, dimensional analysis, okay, dimensional analysis and modeling, any fluid mechanics problem or computational fluid dynamics, okay, fluid dynamics problem, you can contact me. The link to contact me is in the description. You can post your problem and I can help you. Okay, so that's it for today. See you in another fluid mechanics class. Thank you.